Hello and welcome to my YouTube channel. Today is the 31st of July, year 2021, so I'm not far away from celebrating my 38th birthday within a couple of next days that are on the horizon or on the calendar. And I thought this would be a great day to make another tech-based video for my channel. Specifically in this one in particular, we're going to be looking at what you see in front of you that it is located or placed on the desk. This is a HP UPS. It's a service mount rack type design. So this is basically intended to keep those server computers in check so that they don't experience power outages, that they keep running normally. This design in particular is R1500 G2 Intl. So we're going to be looking at this unit, taking it apart, having a brief look inside. Most biggest emphasis will be on the test as such, and that's it. So stay tuned. Before we dive in straight away, let's add a couple of words on basically how the video is going to be divided. So the organizational viewpoint of the ROV. First chapter, let's talk about history. So how I acquired the device, what's wrong with it. Yes, because it does have some minor faults, but nothing too serious. Then we're going to have a look at the unit from a couple of angles, so including a couple of still shots or frame shots. We're going to have a look at the label, all the input or output plugs, buttons, and the likes. And then we're going to start with actually the disassembly. And the first part, we're going to have a much more in-depth look at the battery pack, specifically what's wrong with them and possible replacements. And then the second part of the disassembly is going to be focused on the circuitry. So we're going to have a look at that and discuss how this is all fancy and nicely made. And then we're going to reassemble everything, and I'm going to test this unit, you could say, the much more unconventional way. So without using the original batteries that were inside of this unit in the battery pack as such, or the tray. And then we're going to conclude with a couple of conclusional thoughts, and that's it. So let's start. I purchased this UPS in the beginning of June 2018. It must have been somewhere around that, because I know it was a summer, a very hot day. Even though the ad itself was first published, or the listing, in I think the beginning of October 2017. And the price that this was being advertised for was only 10 euros. And that was a bargain. And that ad was also specifying that the batteries are included. So I knew this was definitely going to be a good steal. However, I did some research and I found out that when you have the batteries inserted inside this unit, the overall weight is around 30 kilograms or so, and that is pretty heavy. So I knew I just couldn't ride my bicycle to that secluded street in Ljubljana and just drive this home. I had to employ the services of another gentleman. I was fixing this guy's computer, helping him upgrade the CPU, the RAMs, and everything else, and basically he owed me a couple of favors, so I employed his services in helping me to deliver this at my home. In the actual ad, it was stated that the fan has issues, so I can't really recall at the moment whether it stated that the fan is completely dead or it just has, you could say, irregular RPMs. And the second reason or fault that was stated was that the UPS has voltage stabilization problems, that there is an error associated with it. And here I immediately thought two possible scenarios are in place. First and foremost, the most common one is that at least one battery in the battery pack of 6 is failing, so has reached its natural life cycle, or sulfation has set in. And the second theory that I was pondering on was perhaps one of the voltage regulators inside the unit on the circuitry has failed or is failing. But when I brought the unit home, took it apart, cleaned it, did the measurements of the voltages of each individual batteries, I realized that basically just a whole bunch of these batteries that were inside had very, very low voltages. But more on that in the next section of the video. Now that we have the history part covered, so now let's have a look at the unit from a couple of angles. Let's first have a look at the labels, all the stickers. Yeah, okay, so that's it. Pretty strong unit, I have to say. Now on the back, of course, this would be your input side, so 220 volts or and the likes. This looks like some sort of a circuit breaker, USB communication port. This is probably the serial port, RS232, I think. Protection for the Ethernet or RJ45 connectors. I think this is a switch with which you can actually finely tune what is the voltage that you're going to use for this UPS. And of course you have the outputs to which you connect your loads to. All of these screws, I think there are some sort of a torque bits or as such, torque screws. Also on the opposite side. There's basically nothing on the side, just a bunch of holes. Nothing on the other side as well, just holes with threads, probably an M3 type. So now let's finally have a look at the front grille or mask as such. So we have the main on-off button. You have to really press this long in order for the unit to start up. I don't know, is this some sort of an alarm? This is probably the light when you turn on the machine that it has AC. Probably this is the light for the alarm that the battery is not working fine, that has low voltage. Probably some sort of an alarm. LED. Apparently it can handle 2 separate loads. So that is interesting. Let's take the mask off. Here we have the fan underneath. There's only one in this unit. So we're going to have a look or listen to the rotation of this, whether this is really not in a good condition as it was stated in the ad. We have the power connector. This is probably the location of the battery bank as such. So we have to disconnect everything. Another label. So this is important. So you definitely cannot run this UPS without some sort of a battery pack installed or some batteries connected. It won't start. So now we can basically start the disassembly. Now let's first, of course, disconnect this power cable. Okay. Now in order to get the battery pack out that is located on the tray underneath, this grill is supposed to slide off, but it can't because it has a Phillips screw here. So we need to remove this. Now this should come off. Perfect. We slide this out. So now we have a couple of pull tabs here, so we just slide the tray with the batteries out. Now let's see how long is this. Woohoo! Quite a lot. Okay. This is quite the battery bank. So you have a total of 6. Let's have a closer look of the ladder. Let's zoom in on the label that we have a much more up-close shot on all the information. So what we can gather is, of course, as I've already stated previously, we have here 6 batteries. Each individual battery is basically 9 amp hour in capacity. It's a 6 volt type. So the entire voltage is 36 volts. This means that all the batteries are connected in series. So for example, the first battery's negative terminal is connected to the second battery's positive terminal, and the likes until you end up basically with 1 plus and 1 minus terminal. If you have 2 plus or 2 minus connections, in the end, when you have reassembled the battery pack, you did something wrong. Each individual battery is, of course, from the same manufacturer or brand as such. It's a CSB type, HRL634WF2, basically a 9 amp hour battery in terms of capacity. Now, in order for you to extract the batteries out, you have here 2 Phillips screws, but also on the other side. So we remove this piece of metal and we should have access. There we go. Now I'm basically just going to reposition the batteries at a different angle so that you'll see the connections. Much pretty in my opinion. Let's rotate it a little bit for easy viewing. So here we have plus, minus, minus, plus, plus, minus. I'm just going to give you a slow overpass. Okay, so now let's disassemble the battery pack and discuss batteries. Just another quick layout before we start discussing about the batteries. The first time when I have disassembled the battery pack and did some initial voltage measurements on the batteries, from those 6, I think only 1 battery, I think it's actually this one that is cracked here at the side, the plastic. Only this one I think had the normal voltage around 6.5 volts or so. The rest had really odd voltages, or basically they were in pairs. I think this one was around 4 or 5 volts, then 2 were that had 3 volts, somewhere in that range, and then the last pair around 2 volts or so. At that time I didn't have a proper 6 volt charger in my possession with many features that modern own, like trickle charging, desulfation, phase, pulse charging, maintain charge, and everything that goes. So I had to improvise somehow with the equipment that I had at that time at my disposal. I was fiddling around with Ossie Callinan's approach. That is, of course, after doing the chemical part of the restoration for each individual battery. So I was playing around with that circuitry, but I didn't have a proper 6-volt input. So I just basically used a 12-volt voltage and sometimes 18650 batteries. So I tried pulsing the batteries in order to get that desulfation or sulfate crystals to remove from the battery's individual electrode plates. I was playing with that for quite a long time, definitely a year. I was probably able to amp up the voltage on each individual batteries, maybe to around 4 volts. But the batteries would get fairly hot even with pulse charging, so I knew something else was wrong with them and I just simply had to give up. Even though this battery was pretty good, and that sort of led me to buy this charger from CTEK. This was basically at that time the first one that I bought. I said, well, why not? Because I can always have good quality chargers because I'm into battery restoration. So I bought this 6-volt model, and this battery, I had it connected to the charger for quite some time and it was appearing to be good. But I think maybe a year ago, this one also just sort of suddenly died. I got the error light to turn on, and after some period of time after that year, the battery also cracked here. So, but still, you know, it is a good charger to own. But I don't think that I was somehow, you could say, cheated out of my experience by just being misled by only one battery and spending 50 or 60 euros to buy this charger and then eventually get sort of cheated out of my experience when this battery died. But nevertheless, all the relentless effort that has been put into trying to rejuvenate these batteries, the success was 0%. I'm still going to make some money off this because I'll fill these batteries up with tap water before taking them to the junkyard, and I'll still get some money for them. Let's add a couple of words or discussion on replacement. At that time when I bought the unit, I already did some research, but also a couple of moments when I started recording this video. What are my options if I wanted to buy new, you could say, stock from the factory batteries, specifically locally, if I was to buy them from Slovenian firms? So the cheapest offer I was able to find revolves around 20 euros or so. Others can go for 23. I also found a completely ridiculous offer of, I think it was around 50 euros or so. So that is just simply insane. I'm not going to go into that sort of expense in order to sell the UPS unit with a new battery pack, because even if I was to go 20 euros minimum per battery, we have 6 of them, 120 euros. UPS devices, well, you know, they're not exactly very essential, unlike a very good graphics card. So that is just too big of a gamble for me to dabble into. Because there is a cheaper way how you can use this unit without buying the original batteries that go into the batteries tray in the unit, but that will be discussed a bit later on in the video when I'll be testing the unit. But I'll just say this for now. Next up on our video is that we take apart the unit, that we have a look inside at the actual circuitry. I have just removed these 3 Torx screws, and then the tray just simply sort of slides off. You push it towards yourself. So let's see. Ah, brilliant. Okay, so let's have a closer look. Now, even though this is a G2 model for the R1500 design UPS from Hewlett Packard, I actually found an interesting review or disassembly guide with great circuitry commentary on YouTube from David L. Jones, but he goes by EEVBlog on YouTube. I'm adding a link to that video for the G3 model review, but I think the circuitry looks pretty much identical, so you can click on that video on the upper right side of your screen, but I'll still give you a slow overpass of the circuitry for my UPS. So where shall we start? Probably around there somewhere. We have a nice solid ground connection. Let's try to get underneath as much as we can. Okay. I forgot to mention when I was doing the review on the back, this is also another slot that this unit has. So we have a very nice solid transformer, Hope the label helps you with something. So now we are at the circuitry, giving you a nice overpass. I know the lighting is not good here in the basement, even though I do have a lot of windows. Just a couple of hours back, it became quickly dark. I thought we were going to have another thunderstorm, but it dissipated, luckily. Oh, just look at those transistors or MOSFETs. Brilliant. So we have a fuse there on the left, the fan. I'll test it out to see if it really works bad or not, because I can't really remember right now how I did the testing at almost 2 years back. Yeah, so it looks pretty decent. Very nice. So we already gone over here. Let's look at it this way. I have to manage always readjusting my external microphone so that the cable doesn't rub against the enclosure of the UPS unit, because every sound will be heard on the microphone. And this is therefore the slot for the battery tray. The first time that I got this unit, it was pretty dusty, so I cleaned everything out as I usually do. Okay, now that I have given you a much more in-depth commentary on the batteries and sort of an overpass of the circuitry, let's reassemble everything and go into the testing phase, where I'll show you how you can still use this unit a bit more unconventionally. Instead of using the original 6-volt 9-amp-hour batteries or something equivalent to that capacity, but most importantly the same dimensions so that they would fit on the batteries tray that slide inside the unit, I'm just going to use these type of 12-volt batteries in order to conduct the test. And I'm going to connect them using the existing cables that were at my disposal when the original 6-volt 9-amp-hour batteries were connected to each other. I had these 3 batteries connected to another CTEC 12-volt charger in order to maintain them so they're in good condition, but we can still do some voltage readings. Let's start with the first one. Wonderful, almost 13 volts. The second. Also good. Let's see the condition of the third battery. Very nice, almost 13 volts. So now all 3 have been connected in series, so we should have 36 volts. Let's again do some measurements. We get almost 40 volts, 38.4, more than adequate. Now let's connect the 2 halves together. We should get a nice spark. Pay attention to the polarity, of course. Okay, we didn't get any, but it is a solid connection. I haven't connected the UPS yet to the mains voltage, so 220 volts. This is basically my very primitive load tester. The cable was salvaged from a broken room heater, and I added a coupling to which I can mount all sorts of bulbs. I have more in the back. This one in particular, I think it is a 150 watt traditional light bulb. I'm going to power on the UPS device by pressing and holding the power button for a couple of seconds. So the LEDs light up very nicely. And the fan, yeah, it is quite loud. So just as it was written or stated in the ad, fan probably needs to be replaced. I'll just remove it from the board and test it on a bench power supply to see how it reacts there. Now we can connect the load or the bulb to the cable, so you can see it drives it with no problems. Wonderful. Nice. So it has no problems running this kind of load. This is, bear in mind, a 150 watt traditional light bulb, pretty much non-existent in 2021 with everybody going on to LEDs. Okay, so now I'm just gonna turn off the unit, pressing and holding the power button. And everything turns off. The unit will follow. Yeah. Okay, so this is now turned off. Now I'm going to actually plug in the unit or the UPS into the AC extension cord. Come on. Yeah. So this is how it reacts. So it's probably already charging the batteries. It also turns on automatically. Very nice. But the fan is less loud in my opinion. Oh yeah, a couple of seconds, it started revving up. Maybe I just need to add a couple of washers or some rubber feet underneath to dampen any sort of vibrations. Maybe that will lessen the vibrations. Okay. Let's see if this is turned on, and let's try turning it off. Okay, this is interesting, but the fan doesn't go off. Okay. While in this position, let's do some voltage readings. Let's start here at basically the all three connected to each other. So 40, well, almost 41 volts. Let's try individual. 13.7. Yeah, okay, let's also check this one out. The same. And this one again, 13.5 volts. The unit is now pretty much turned off, but it's charging the batteries. When I have disconnected the AC mains cable from the extension cord, also the unit finally shut off, and most importantly, the fan became quiet, so we can have a couple of words. I found myself asking this question ever since I discovered this trick, how you can use this unit 2 years ago. So instead of using the traditional setup of 6 volt batteries of the same capacity, going with the technique by only employing 3 12 volt batteries, connected them in series. How is it with charging? Are each of the 3 individual 12 volt batteries, when you have the entire unit connected to the AC mains, how will they be charged individually, voltage wise in particular? Will each battery be charged with 12 volts or 6 volts? So this is an interesting question. Of course, we know that amperage wise, each battery's internal resistance limit how much charge each battery is going to receive, but having this sort of configuration is a bit more puzzling. Maybe somebody in the comment section will enlighten me. Now I'm going to conduct another test, so running the unit only by batteries, but I'm going to measure the voltage, the common voltage of all 3 batteries to see how it drops when I have the 150 watt bulb connected to it as a load, and then also measure the individual voltages of the 3 batteries. Let's start by turning the unit on, of course. So we're gonna just wait for this to play out so all the lights stabilize. Okay, so this is it. So we have 37.5 volts basically under no load, even though the unit itself is taking up some power, of course. Okay, let's connect the load. So the voltage drop, well, it's not very significant, but it is present, of course. So I do have the bulb hanging almost towards the floor. Okay, now let's try individual battery voltage to see how the load affects it. Okay, let's go to the next battery. Wow, so this one is quite bad, quite a strain. Probably not yet fully recovered. This one is pretty fine, much better than this one, I think. Oh yeah. Okay. From this moment on, I'm recording this video the next day, so the 1st of August, year 2021. Today is not a good day for making a YouTube video because we had a thunderstorm about an hour ago, but overall the entire day it has been quite cloudy, so the lighting in the room, especially when you're located in the basement, and even though you have a decent amount of windows, and the lighting in the room is not very optimal, so I had to turn on the light in order to maintain some sort of a decent level of crispness or sharpness of the recording such. So don't let that bother you, but just as a sort of a heads up. So the previous day we played a little bit around with this traditional 150 watt tungsten wire bulb as a replacement load tester to stress the UPS unit whether it can handle such a high load, driving only pretty much these three 12-volt batteries. And of course the test was successful, so I thought today we can try out the rest of the, you could say, bulbs that I had in that bag. This one I think is 40 watts, 25, 1.4. This one is an LED bulb that has been fixed. It's 14 watts. I don't know how much these consume, but still we can try these out as well. Yesterday I also removed this fan that is cooling down the MOSFETs on those two massive aluminum heat sinks, and I tested it on an individual, you could say, standalone bench power supply, and I didn't notice the rattling that it has while it is connected or inserted into this unit. So, but still, nevertheless, I added some sort of a rubber washers that were discarded, and I've put them between the enclosure of the unit and the actual fan in order to somehow lessen the vibrations. Maybe you'll tell me whether the noise fan is less obnoxious than it was before or not. Well, let me know in the comment section nevertheless. But before we proceed with the experiment, let's quickly just check the individual battery voltages, because I had the unit connected to AC mains yesterday for I think 2 hours in order to charge the batteries a little bit. Let's see. Cool, almost 13.2 volts. And this one here, also the same. I think this one is a bit lower. Yeah, but still more than enough. So I'm just going to leave the digital multimeter in this position, so I'm measuring the total voltage of all three batteries while we'll be conducting the experiment. So now let's just turn on the unit. So we have a better view of the lights. Okay, so now we are running just by batteries alone. I don't have the UPS connected to AC mains. As you can see, the cable is disconnected. So let's start playing. Let's start first with the 40 watt bulb. Okay, it can handle it, of course, naturally, because if it could handle the 150 watt bulb, I'm sure it can also handle almost pretty much 3 times less. Fine, let's remove this. Let's use the 25 watt. Also pretty much fine. Let's bring this closer to the camera. Okay. This one is interesting. There's something broken inside. But what do you know, it still works. This is supposedly 1.4 watt, a different design. Yeah, okay. This one works as well. It's not that much of a strain. Okay. Now let's try out this one, which was fixed. There are great videos on this topic, how you can fix these LEDs bulb that have gone wrong. Wonderful. This one is a nice white color. Now these two, let's see. Nice. Also white in color. This one works too. Maybe I should try connecting a laptop to the UPS instead. Okay, fine as well. Now let's just reconnect the unit to AC mains. Fine. So now it should start charging the 3 batteries and the voltage should begin to climb. So definitely an interesting way how you can use this HP 1500 VA or 1000 watt uninterruptible power supply without employing or spending 120 euros to buy the original batteries, because you can just buy let's say 7.2 or 7.5 amp hours for as low as how much is it 13 or 15 euros, and you just buy 3 brand new. That's 45 euro expense, and you can still use this unit instead of spending 120 euros minimum. At the end of another tech-based tutorial or video as such. In this one in particular, people are dissecting the HP R1500 GTU Intl UPS unit. I basically showed you an interesting trick how you can use this device without spending a minimum of 120 euros if we're talking about buying the replacement batteries locally. So buying 6 9 amp hour batteries in total to use the unit as it was intended to do, but instead you can spend a minimum of, let's say, 30 euros if you buy the batteries used, or 45 if you buy 3 12-volt batteries of, let's say, 7.2 or 7.5 amp hours in capacity, and connect them in series and still have fun with this device, make it usable. I do hope that you have found the video somewhat informational, that you learned something new. If I missed anything, let me know down below in the comment section, which is always open, and you're invited to a civil discussion. If you haven't liked the video yet, please do so. If you have decided to share it, thank you very much. If you're an existing subscriber, well, thank you for staying with me. If you're a new viewer, please subscribe. So today has been the 1st of August, year 2021, and hopefully we'll see you very soon in another tech-based video. Bye bye.